Good morning. So, hopefully you're in the right place. This is going to be a talk on chaos. Okay? We good with that? Okay, so this is actually a talk about, it's got kind of an enemy in this talk. We've got something we're going to try and defeat. And I have to introduce it first. So the song introduces the enemy. Then we're going to defeat the enemy. And then at the end, we're going to celebrate the fact that we've defeated the enemy. Okay, let's try this. Thank you ever so much. I should warn you I have a cold, so if I speak with a slightly crunchy voice, it's not because it's just emotion. It's also because I'm also struggling to breathe. Okay, so first thing to warn you of in this talk, I don't have any slides. Although technically, the very fact that I have to show a slide that says I have no slides indicates I have a slide. So I'm already confused. But the important thing isn't about the slides. The important thing today is to address a real issue in our lives. You see, development would be the easiest thing in the world without this particular enemy. And I'm talking, of course, about production. So the first thing we need to understand about production is we need to adopt a very different attitude to it. You see, production isn't passive. It's not a nice place to be. One of my best friends, Josh Long, talks about production being the wonderful place that your software ends up. I think of production being a war zone that I drop my children into. And it's fair to say it's not a passive environment in the sense that, actually, there's an analogy for this. Anyone who came on the course yesterday has heard this analogy. You see, who here has driven a car recently or knows how to drive a car? I know this is debatable in London, right? Okay, so when you're taught to drive, assuming you were taught to drive a car, and you weren't just, grabbing someone's car and going off for fun. When you're taught to drive a car, you're taught to drive defensively. You're taught that everyone else can't see you, and assume they can't, and you'll be safer. Don't never assume they can see you. Now, I'm a motorcyclist. Next year, I'm riding from Los Angeles to Chicago for a conference. I don't know why, but I am. And I love riding my bike, but the first thing you're taught about riding a motorcycle is that everyone else can see you and they want you dead. That's kind of like production. That's what we drop our precious little pieces of software into. We drop them into this environment that wants them dead. The network hates you. The hardware hates you. The clouds really hate you. And as for your users, they hate you even more. And they probably know where you live. They also know that you've gone home. And that it's your Friday night. Or it's your Sunday morning. And therefore, they're going to wake you up. Okay, so how do we deal with this hyper-aggressive environment of production? Because unfortunately, our software can't avoid it. It'd be lovely if we didn't have to put software in production. We could just wax lyrical on some great code for ages and never make any money. Actually, I've done startups like that. But generally speaking, if it's not in production, it's not making us money, which is unfortunate because production hates us. So, recently, I've been helping people build microservice-based systems. I feel a little bit like a criminal, in the sense that I'm not entirely sure everyone knows what they're getting into when they build these things. I assume everyone here has built great microservice-based systems in the past. And they're all really happy with how they're running in production. And right now, you're not even worried about them, because they're just great. Most of the systems I get introduced to aren't like that. I'm a consultant. I apologize for that in advance. As a consultant, you don't get called when everything's okay. It's unfortunate. It's quite a depressing living, actually. It's kind of like being a doctor. No one ever comes to you when they're healthy. Someone will phone me up and say, we've done this microservice thing. We'd really like you to come in and tell us why it's better. And I sit there and go, why did you do it in the first place? And they go, well, we had a big, all right, we copied someone. We did what they did, and it seemed like it might be better then, and it's not really. So what I'm talking about today, I suppose, is how to avoid that problem. And it becomes unignorable in production. You see, we're now deploying distributed systems as our mainline production systems. Almost every system I work on is a complex and chaotic distributed system. This is not the way it used to be. When I first started writing software, I won't talk about my very first story because I spent all weekend coding something without anyone telling me what the enter key did. And so I'd blown the keyboard buffer several times. When I first started around software, it was always simple. It was standalone. It didn't have all this complexity in it. And you know what? You could, taking on what Kevlin was saying earlier, you could have some confidence in these things. You could build your software and have a good idea that it probably works. And if it works for me, it probably might work for you. Now we build complex distributed systems that chances are don't work for anyone. And it's difficult, and it gets so obviously difficult in production. But it's essentially difficult. Okay? We can't graft on more tools and practices and processes around these things to try to make it just a bit better. There's no easy solution to this. Production is hell, and distributed systems in production are hell's worse cousin. And that's actually the norm. So the first thing we need to do is understand that a little bit better. You see, we want to improve this system. When we drop things into production, and the way that we manage production, we probably want to adopt an attitude, at least, where things could get better there. And that's difficult when it's a chaotic or complex system. You see, when it's a simple system, the answers are best practices. Just go do X. All right? When I deliver the production microservices course, there's probably only one thing I can say, just go do, which is distributed tracing. If you're not doing that, then you will want to do it at some point. But everything else comes with the consultancy caveat of it depends. But I want to dig into that a little bit more so we can understand what that means to production. The reason it depends is because it's never a simple system with a distributed system. It's never a simple system when you consider the sociotechnical system around it. See, production isn't on its own. It's surrounded by people like us that are trying to make this thing work. We're trying to deliver on the promise of microservices, which I'm hoping everyone knows is supposed to be highly evolvable systems. Systems that can keep up with the pace of change. It's kind of it. I don't care how big your microservices are. If you've achieved that, however you've done it is good. But in achieving that, we generally evolve these systems in small parts frequently. And so we build these systems around them of people, of platforms, of infrastructure and applications, trying to surround it so that it can evolve quickly. And the hardest part in that problem, the hardest part of production, is not the technical parts. It tends to be the people. So I used to be an architect. I'm a recovering architect. That's the phrase. As an architect, I had a problem in that when I was dealing with people who were working with distributed systems in production, most people ignored me. That's the sort of architect dilemma. You may have the best advice in the world. You will be ignored. Why? Because you're not writing code. Worse than that, I was an architect working with very smart people in a very, very smart organization. Their whole hiring policy was, have you got 25 years of experience? You're in. Have you got 20 years of experience? Maybe you're in. Have you got 15 years of experience? You're a junior. Now, as an architect, particularly a relatively short British polite architect, getting these people to listen to me about what they might consider in production was a nightmare. I was saying good things, at least I think I was. I was saying consider circuit breakers, bulkheads, isolation between parts of the system, reverse Conway's law. All of these things sound wonderful, and they're completely ignored by everyone because they're smart people, and they don't see why they should care. But I had an edge in that I'm a trained counselor. I know how to change people. It's a horrible skill. I don't know how to change myself, by the way. It never works on yourself. But other people I'm pretty good with. And so one of the things you're taught is no one changes unless they feel some pain. It's kind of the naughty secret of it all. Unless you feel the pain, you won't change. You're waiting for that moment of realization. So what I was watching as I was walking around giving people advice about production is I was being completely ignored because no one felt the pain. Okay, so the first thing I want you to learn about in this particular session is how to introduce pain. Should have called this sadism or something. But yeah, how to introduce pain so that people change. See, the problem of production is it can be ignorable pain. So we have to make it unignorable to the development teams. And the way we do that is we say, you write it, you run it. It's a beautiful phrase. For me, it's what DevOps really means. You write it, you run it, you panic, you learn. This was a key differentiator for me as an architect. By actually making people run their stuff in production, suddenly they were coming to me for my advice, rather than me putting out my evangelism and education and being totally ignored. And I thought a bit deeper about this. I thought, could this be extended a bit further to the actual software itself? And then I was working with a group of people where they said, yeah, we could do this. So one of the things I was struggling with is how people could consider things such as circuit breakers. The problem with non-functional requirements is they're eminently ignorable. Everyone is concentrating on ship feature, ship stuff. And we all assume that software development is a sort of a continuous accrual of features. Although I don't, because I work with companies where they're just trying to turn stuff off half the time. There's at least one bank not far from here that's got 137 systems, of which they understand what roughly 25 to 30 are doing right now. And they're trying to turn the others off. They've got a great phrase for it. It's called digital transformation, otherwise known as turning stuff off. So it's not that sort of thing. But anyway, I was trying to get people to think about these circuit breakers in production and being ignored still. I thought, well, maybe I could make production help people feel some pain. So me and my colleagues, we created this little piece of software, which on the surface of it, I imagine is probably the least understood piece of software in the world. We called it the Chaos Monkey. And all it does, if you're not familiar with it, have a go with it. It's great fun. All it does is kill stuff. And it doesn't kill stuff in a nice way, by the way. It doesn't turn off virtual machines nicely. It deletes them. It goes full on. Okay? Because we decided that we wanted people to feel some pain. I wanted people to feel the pain of depending on parts of the system that they shouldn't be depending upon. They were making assumptions about the state of the world, and I was going to ruin those assumptions. And so I did. And you know what happened? They all started asking for things like circuit breakers. Didn't know what they were, but they started saying, well, okay, so I can't depend on that thing being... No, you can't. No, it's a distributed system. That goes away. Okay, what do I do to deal with that? Right, so now we can go into some solutions. And I got further with this. I kept going. As I was continuing to consult, we extended the toolbox. We ended up with things that would do security problems. We've got things that would take down, take down the networks for fun, would inject poison pills. What a wonderful job being an architect is, by the way. Writing that code was the funnest thing I've ever done. And I do it all the time now. But that's not because I'm evil. It's because we want something from the system, because it's a complex distributed system. We have to treat it very differently. You see, we used to build systems that we would decide were robust and resilient, right? We would aim for that. No one would decide not to go for robust and resilient. You can even see whole frameworks out there that say to you, this is how you build robust and resilient systems. The problem with robust and resilient systems is they come at an incredible cost. See, the difficulty with robust and resilience is that, at best, it ignores stress. At best. At worst, It resists stress. Hang on. We're building a microservice-based system. And it's supposed to deal with change. And change is a stress. So if we build a beautifully robust and resilient system, and possibly a robust and resilient delivery system for it, we can't change it. So robustness and resilience isn't the end goal. You probably don't want the other thing, by the way. What we assume is the alternative, which is a fragile system. My favorite sort of analogy for a fragile system, just so you can know what it feels like, is that moment when you're about to do a keynote talk and your operating system decides to update itself. And you sit there just hoping the darn thing comes back. That's what fragile feels like. So no one usually aims for fragile. So a fragile system falls apart in the face of stress, which is probably not what we're looking for. It turns out we want a different sort of system. And that's something we realized really early on working on these systems, is we wanted something different. And we called it, well, we borrowed a term actually from an economist, called it an antifragile system. What this is a system that can thrive on stress. And when I say system here, I don't just mean your stuff in production either. I mean the whole sociotechnical chaos of people, process, practices, production, code. When you have that entire system, the only way of dealing with it is to treat it as an anti-fragile system, a system that has to learn. It has to gain from stress. And this is what we realized, is that by running these crazy little pieces of software in production, we were learning as an organization. Now, I've read a lot of fancy management books about how organizations become learning organizations. And they're beautiful books, don't get me wrong. But I'd never seen it in action until I saw these tiny little pieces of software causing things to break in production. Suddenly, there was a learning loop in place. Not just a learning loop, the mecca of learning loops, the double loop learning loop. If you aren't familiar with double loop learning, single loop learning is we've got a strategy, we sort of validate the strategy, we've learned something. Double loop learning is, what was the assumption that backed the strategy? Well, maybe we'll question that too. So you're continually going back and questioning your assumptions as well. One of the assumptions we questioned is, what sort of system are we trying to build here when we deliver software? Well, it turns out we're trying to build an anti-fragile system by challenging those assumptions. And as we delivered all of these different little pieces of chaos, we found that the teams were learning. These incredibly smart, highly arrogant, very experienced people were learning about what to do better. So this is why I wanted to talk to you today about chaos, because one of the things I see when people are doing software development, microservices in particular, is that they don't know how to improve the system. They kind of know they need to consider things like externalizing config. They know they probably should consider bulkheads. They probably should consider circuit breakers. But these things become quite ignorable factors. What we do with chaos is make them unignorable. We make them felt, and then we help people change. Okay, so this has now got a name, this discipline. It didn't have for a while. A long time, everyone thought, and whenever I talked about this, everyone thought it was insane. I would talk about running chaos experiments in production. Don't run in production. Why would anyone run in production? Production isn't where bad things happen. I've had clients say that. Production is where it works. No, production is where it all goes to hell. Okay? Protect production. Why? It's leverage. It's where the good stuff can be learned. It can be felt there. But you don't have to do these things in production. You can do them anywhere they're felt. But now we have a name for it, and it's a real epiphany in the industry. It's really lovely to be able to talk about this today. Actually give it a label. We now call it chaos engineering. You can be a chaos engineer. In fact, and I have done this, I own my own company, so I can give myself any title. And so I'm a director of chaos. Fantastic. What a great living. But the thing about it is it's a terrible term. We're really bad at naming things in this industry. The problem with chaos engineering is who buys chaos? When you go to speak to a management individual, someone on the board at a company, if you turn around to them and say, what you want is chaos, they'll say, no, we don't. We already got that. We prefer it working, which is understandable. So you don't say that. I don't say that. I don't walk into a board meeting and go, I'm going to sell you some chaos now, sign a check. What I do is say, how do you want to improve your system? How do you want your system to learn and get better? Because it's a chaotic, complex system. And we can't just graft on best practices here, because they'll be ignored at best. Actually, all of this theory around these chaotic systems and complex systems comes from a thing called Cynefin. If you haven't bumped into Cynefin before, I'll tweet it later as the spelling because it does not spell the way it sounds. Okay? But the idea is that different systems need different approaches. A simple system, best practices. Just do this. Something that's more complicated, generally good practices is all you got. So consider this is one way of thinking about those. As soon as you get around into complex and chaotic systems, which is what we deal with when we're building distributed systems with teams of people involved, the best you can hope for is to change the system in small ways and detect what's changed and see if things are going better. You can't come up with best practices. We've seen this before. You've probably experienced this where someone comes in and says, you're going to do agile now. What we're going to do is we're going to give you all of the sort of brainwashing we can possibly give you, and you're going to come out of here and you're going to be all dangerous and agile. And what happens is all those companies generally sort of spring back to normal life afterwards and don't end up very agile at all because they haven't really changed. The reason that doesn't work is because they're trying to graft best practices, as it's seen, onto a complex and chaotic system. And a complex and chaotic system does not respond to best practices. If anything, it ignores them. So in a chaotic system, you have to make it a forcing factor. You need to make something change. That's what we were doing with chaos. So chaos engineering is really about what do we want to learn about our system? What do we want to learn to improve? Just reducing it down to the technical for a moment. If you're working with just a distributed system in production of microservices, how many here are using microservices that use REST? Really? Is it restful? How restful? Well, I love it because every company I go to say, yeah, we're doing microservices, RESTful microservices. And then you look at it and you go, well, it's HTTP, I'll give you that. But it doesn't matter. That's not the point, by the way. It's not the point. It doesn't matter. But in that system of chaos that you have in production, what we can do now is we can stress it to learn from it. And that's what we're doing when we run chaos experiments. So the lovely thing about chaos engineering is it's got nothing to do with chaos. We're not causing chaos, ever. In fact, there's a rule with chaos engineering. If chaos is a surprise to people, you're doing it wrong. The first question in chaos engineering is, if we do this to the runtime system, what happens? And if the answer is, it breaks, don't do it. You've already learned. I get that complaint a lot. You know, I was talking to banks recently, of all places, where they say, we can't possibly run Chaos Monkey in production. It will ruin everything. Good. Well, you now learn the lesson. Why don't you try and deal with the fact that these factors do happen, improve the system, and then when you think it won't break the system, we'll run some chaos. I've done this at a few organizations where I'm sort of vaguely threatening. I say, chaos is coming. And I warn them. I say, it's coming soon. You know, 6 months' time, you're going to have chaos run on this system. We're going to destroy VMs. We're going to destroy pods in Kubernetes. We're going to exhaust resources on these systems because it happens in production. Actually, that's an interesting conversation to have anyway with people. The amount of times I've had conversations with developers where they say, no, in production, none of those things happen. And in the corner, there's usually someone looking fairly grizzled and upset with that, and possibly sometimes laughing. going, oh no, it happens all the time. And you say, if it happens, why not make it happen? Because then the software gets a chance to be improved to deal with it. That's all we're doing with chaos engineering, is we're turning these factors that happen into something unignorable. And it gets better. You see, when we start to construct our chaos engineering experiments, we ask ourselves things such as, what would happen if this broke? And then, if we don't know, then what we're doing is we're building confidence. We're going to run the experiment, and we're going to find out what happens. And then we're going to improve the system to deal with it. But it gets better when you encounter things you couldn't possibly dream of. One of the slides that was up earlier in part of the song was when Netflix went down. I can remember the day well. I got a phone call not long afterwards. Netflix has gone down. Does anyone remember why Netflix went down? The slide went past really quick. So Amazon went down. Yeah, a whole region disappeared. And I can remember the conversations afterwards, everyone going, they're doing that chaos stuff in Netflix. Didn't help them then, did it? The important thing isn't the fact that what we already had as chaos wasn't helping us at that point. The important thing is what we did next. When we encounter what we call a black swan, which is a situation we couldn't possibly anticipate, we don't just fix the problem. We continue to make it happen. It becomes part of our toolkit. We now have Chaos Kong that will take whole regions of Amazon down. To show, and we run these things automatically, we run these things carefully, I should point that out. It's fair enough to say if we completely destroy the universe as far as our chaos is concerned, we don't want to do that in the middle of someone trying to stream House of Cards. But we do it in production. We do it where we can feel it, and we carefully schedule it. Another thing about chaos, we know it's coming, we schedule it, we're careful. An experiment is not a surprise. We know when we're going to run these things, we have an idea, we have a hypothesis about how the system's going to deal with it. But then we're also looking to see what parts of the system don't deal with it. And that's what we learn. That's how it gets better. So if you're not doing chaos engineering in your systems, then I wholly recommend you look into it. And it gets even better. There's a free book on it. You don't even have to buy it. There's a free book that introduces the principles of it and how to do it in your organization. It even gives you a maturity matrix that says, don't do this if you're not this high. Above that, you'll be okay. And the first rule of that is, don't run chaos if you already know the answer. It's going to break it. So what does a chaos experiment look like? Well, I've written a little toolkit that does chaos, and you can download it. There'll be some links at the end. And it's a nice way of exploring it in a small way. The idea is you create an experiment. You have a hypothesis. And that hypothesis is based on something called the steady state of the system. If you don't know your steady state, you can't do chaos. You'll learn nothing. You need to have a comprehension of your system that says, this is what normal looks like. And a microservice-based system in production, normal can be pretty varied. But you need a picture of steady state, otherwise you can't do chaos. Otherwise you just don't know what you're impacting. So you build your steady state picture, which is usually done using a collection of probes that says, I'm looking for this, I'm looking for this, I'm looking for this. That seems to be steady. Then you run some actions, such as destroying networks, such as anything you could think of that actually happens in production. And then what you do is you look at how the system responds. So you have another collection of probes that say, what is my steady state afterwards? And then you go straight to the teams that are working on the system and you say, we need to deal with this. This happens. The other thing is we automate this stuff. So we don't just do this in isolation once a year. We continuously do it. A nice way of thinking of chaos engineering is continuous disaster recovery. Now, most organizations have a disaster recovery strategy, but it tends to be the least exercised thing they have. I actually asked a question 2 weeks ago, who here has exercised their disaster recovery system in the last week? And one hand went up. And I was like, oh, great. And he said, yeah, we had a disaster. That's the worst time to exercise a disaster recovery strategy. That's the hard time. So what we do with chaos is we make disaster much more normal. Happens all the time. And then we get better at dealing with it. The system improves, we get better strategies. And we don't start by automating responses. We don't immediately leap to circuit breakers or anything else. What we generally start with is playbooks. Now, if you aren't familiar with playbooks, think how-tos, but the audience that are reading them are stressed out of their minds. So you don't want them making big decisions. You want it to be so simple. It's got to be almost the level of press this button, pray, hope, whatever works for you. It has to be that level. Otherwise, they're not going to be making informed decisions at that point. So when we do chaos engineering, the way we come up with these things is we organize these game days. Game days are brilliant fun. If you do one thing, do a game day. Okay? It's very simple. Get everyone in the room and pretend that production's broken. Or even better, break it. Or if you can't, break it in staging. And just see how people will learn about the system. Immediately, you get developers who have to look at logs. Now, we talked about this yesterday, and one of the people on the course actually asked, how do I get developers to care about producing logs? Put them in charge of fixing the system back together. They'll want their logs. So immediately, you get an awareness of operations. You get an awareness of the recovery scenario. And then you codify it in a playbook. And so it's a very valuable day. You do that 2 or 3 disasters in a day, and you're going to learn a huge amount about your production microservices system. And then you can start to decide, do we want to automate those failures? And if we automate them, the first thing you'll notice is people get fed up running the playbook. So instead, they'll automate the response. And so the playbooks get reduced down as the automated responses get better. I've seen this in many companies now, and it's such a fundamentally better approach to building and running microservices in production. Okay, so to close out the talk, really, I just want to finish on a little anthem. I'm hoping you're going to go away thinking that maybe chaos is something to look out. Hopefully you're going to go away thinking chaos is badly named, and chaos engineering is a really ridiculous name for it. It's a disciplined, scientific, careful approach to improving a distributed, complex, or chaotic system. Unfortunately, that's not easily summarized in a title other than chaos engineering. Plus, chaos is cool. So this is I'm just going to close out on a little anthem for us that hopefully means you'll take this away and start looking at doing some chaos of your very own in production. Or staging if you must. In the name of learning. Thank you very much.